Hello everyone, welcome to another video on integration. In this video I'm going to be talking about trig substitution, and the last question, I have 5 questions. The last one will involve U-substitution and integration of log functions. So the first one for today, it says integrate the integral of dx all over x squared plus 2x plus 5. Now if you look at the denominator here, it's a trinomial or a quadratic function, and in the numerator there, if you like, there's a 1 dx. Now there's absolutely no way you can change 1 to turn it into x. So in that case, what we need to do is to complete the square of the denominator, which is a trinomial. And once we complete the square of this one, then we're going to look at the tan substitution that I described in the previous video. Okay, so let's go through this and let's see how it works. Right, I'm gonna capture the question first. This is page 1, I'm gonna call it. Question 1 says the integral of dx all over x squared plus 2x plus 5. Now completing the square of the denominator, the process, remember, I'm gonna remind you, I spoke about it in the previous video, but I wanna remind you on this one. We have x squared plus 2x plus 5. Now to complete the square of this, you look at the coefficient of x, which is positive 2. In step 1, we divide it by 2, and the answer is 1. In step number 2, we take what we got in step 1, we square it. Obviously, it's 1 again. And in step number 3, we're going to add. In step number 3, we add this one here. And obviously, because we don't want to change this, we'll add and subtract. So, as follows, watch carefully. This is going to be equal to the integral of dx all over x squared plus 2x. Now, as I explained that the coefficient of x is 2, divided by 2, the answer is 1. Square it and add and subtract. So we're going to say we're adding 1 and we're subtracting 1. And obviously we have plus 5 there. So don't forget that. Right, now, so what is minus 1 plus 5? That's plus 4. That takes me into the next step, which is the third step according to this. The first one was just capturing the information that we had. And so what we have now is x squared plus 2x plus 1 plus, remember, minus 1 plus 5 is plus 4. Now, this part here is a perfect square now. This part is a perfect square now. So factorizing that, we get dx all over, obviously you get x plus 1 or squared plus 4. Try to expand this, you'll get this one here. Now, at this stage, what we're going to say is we're going to factorize this. I'm going to take 4 out as a common factor. Watch how I'm going to do this. So this is going to be the integral of dx all over, and I'm going to say take 4 out as a common factor. 4 into this, I'm going to have x plus 1 all squared all over 4, and then plus 1, if you see what I mean. Now, so this 4 is dividing, I can take it out. So this is going to be 1 over 4, the integral of, watch what I'm going to do here. This part here, I'm going to write this one as a square of one expression. So this will be, watch carefully, x plus 1, and I'm going to say all over 2. The whole thing has to be squared like so, and then plus 1. And obviously, if you remove these brackets, you're going to get this expression here. And then you have dx in the numerator. Now, at this stage, I'm going to let tan theta be equal to this. Remember, I told you we're going to use tan substitution. So now we're going to say, in this step here, we're going to say, which is our page 2 now, we're going to say, I hope you can see it there. Yeah, you can see the expression. You can see the expression there. Let me just move it down so that you're able to see it clearly. All right, fantastic. Now, I'm going to say, at this stage, I'm going to say let tan theta be equal to x plus 1 all over 2. Now, if you like, this can be rewritten as half of x plus 1 over 2. and we have tan theta is equal to that. Now we differentiate both sides. Derivative of tangent, we obviously know that it's sec squared theta, and we're going to say d theta equals derivative of x is 1, and I'm just going to have half dx. Derivative of half is 0 because it's a constant. Multiply by 2 both sides, you're going to get 2 sec squared theta d theta equals dx. Now this expression must come into the place in the numerator there. So now this integral then changes to 1/4 the integral of 2 sec squared theta d theta in the numerator all over. Remember, in that place now I must have tan, but it has to be squared. So I'm going to say all over tan squared theta plus 1. Now, if you remember, in the previous video I spoke about this, that we have sine squared theta plus cos squared theta. The answer is always 1. And if you divide throughout by cos squared theta, assuming cos squared theta is not equal to 0, you're going to have sine squared theta all over cos squared theta plus cos squared theta all over cos squared theta equals 1 all over cos squared theta. This is tan squared, as you can see, theta plus this is 1. What do we have here? Sec squared theta. So sec squared theta is actually equal to this. So that expression there, in the denominator must be replaced by sec squared theta. So I'm going to take the 2 out. So this is going to be 2 over 4, the integral of sec squared theta d theta all over sec squared theta. And notice that these cancel. And so what I have now is half of 1, if you like, d theta, which is basically equal to half of theta, and I have to say plus c because this is an indefinite integral. Now we must go back and check what is theta, the relationship between our original variable and this theta variable here. If you check there, tan theta equals this, which means if I want theta, I'm going to have to take tan inverse or the arctan on both sides. So theta is going to be the tan inverse of or inverse tan of x plus 1 all over 2, or arctan of x plus 1 all over 2. So this one then gives us our final solution of 1 over 2 inverse tan or tan inverse of x plus 1 all over 2, and then we have to say plus a constant c. So that is our final solution to our question 1. Right, tan substitution coming out very clearly there. Let's look at question number 2 now. Question number 2 for this in this video is going to be this one here. This is question number 2. Remember, I promised that I would come with questions involving trig substitution. So we have question number 2 here. It says integrate the integral of 1 over square root of a squared minus x squared dx. Now, if you look at first year and second year calculus, this is usually given as a formula. They've given you this and then they give you a solution there. And I want to show you how you come up with that solution. All right, so let's go to our next page here. The last page, let me just check. The last page was page what? For question 1. We had page 1, page 2. We ended on page 2. Now we must start from page 3. So this will be page 3. And we're dealing with question number 2. Question number 2 says the integral of 1 all over square root of a squared minus x squared, and we have dx. Now at this stage I'm going to have to factorize this. I'm going to take a squared as a common factor. So how does it work? So this is going to be the integral, and allow me to put dx in the numerator now, dx like so, all over square root of, and I'm going to factorize that as my common factor is a squared, and I'm going to say a squared into a squared, the answer is 1, minus, and there it's going to be x squared over a squared, if you catch what I'm trying to say. Because if you expand this, this will be a squared, and that the a squared will cancel that, and you have x squared, as you can see up there. Now this one I'm going to write it as a square of one expression like I did in question 1, and I'm going to take square root of a squared. It will be a, it must come out. So this will be the integral, watch this, dx all over a, and I'm going to say square root of, watch this, 1 minus x over a, and I'm going to put the whole of this squared like this. And a is dividing, remember, it's a constant and it's dividing, it must come out. So we have this integral of dx all over square root of 1 minus x over a, and I have to square this. And now I have to use trig substitution, and it's going to be the sign substitution. Remember, we've looked at tan substitution. Now it's going to be the sign substitution. Now I'm going to say let sine theta be equal to x over a. Differentiating, remember, a is a constant, so derivative of sine is cosine. So I'm going to have, let me erase this. My hand misbehaved there again. I'm going to have cos here. Just remove this one here. I'm going to have cos. If I differentiate on the left hand side, I'm going to have cos theta d theta. On the right hand side, remember, it's just dx, so it's going to be 1 over a dx. Now multiply both sides by a. I'm going to have a cos theta d theta is equal to dx. Now the numerator there must be replaced by this, and I'm going to take this one into that place. Let's go to page number 4. Watch what happens in the next page, page 4. Can you see it from there? Yes, you can. I'm going to move it down again a little bit. Right, there you go. Now, so what I'm saying basically is this integral then changes to the 1 over a, the integral of, instead of dx, I'm going to put a cos theta d theta all over, and I have square root of 1 minus, remember, in place of x over a, put cos sine theta, which has to be squared. So this will be sine squared theta. Again, I must remind you of this expression which I gave you earlier on, and I'll just get a page here. Right. Remember this expression here: sine squared plus cos squared, sine squared theta plus cos squared theta equals 1. If you solve for cos squared theta here, cos squared theta, you'll agree with me that you get cos squared theta equals 1 minus sine squared theta. So in the place of this, we must put cos squared theta. So then there, in a whole denominator, square root under the square sign, I'm going to put cos squared theta. So this is going to be 1 over a, the integral of a cos theta d theta all over square root of cos squared theta. And what is square root of cos squared theta? Well, this cancels that. So what we have now is, take a outside, a over a, the integral of cos of theta d theta all over cos of theta. And these cancel. So, and outside here you have 1. So just the integral of 1 d theta, and the answer is theta. And I have to say plus c. Let's move back to here. Remember, if you want to solve for theta here, you're going to take the inverse sign on both sides. So theta is gonna be equal to sine inverse of x over a. So this changes to sine inverse of x over a, and then we are supposed to say plus c. And that's our final solution to question number 2. Right. Remember, this is where we're coming from. The solution to this one here by trig substitution is this one, our final solution. Right, page 5. Page 5, and we are going to start with question number 3. Page 5. Our question number 3 for in this video is going to be the following. This is our question 3. Now, a bit of trig substitution, but in a very tricky form of it. So the question says integrate the integral of 1 over square root of 4 minus 3 x squared dx. So how do we go about this? Well, the same approach. I'm going to have to factorize this. I want to have a 1 here. For sign substitution, I must have a 1 here. And the reason for that is because of what I showed you. Let me just get that page quickly so you can see what I'm talking about. Just get that page, a lot of paper, but I think I'm going to manage to get that page. All right, I'm just going to write it. Just gonna write it so that we don't waste too much time. Let me just write it here. So what I'm saying is I want to have a 1 in that place. The reason why I want to have a 1 in that place is because of the following. Remember we said sine squared theta plus cos squared theta equals 1. If you solve for cos squared theta here, you're gonna have cos squared theta equals 1 minus sine squared theta. There must be a 1. Whatever you have there will be replaced by sine squared theta. So here there must be a 1 here. Whatever is here will be replaced by sine squared theta. So how do we go about this? Well, let's go through this on page 5. Let me capture the question first. The question says the integral of 1 all over square root of 4 minus 3x squared, and we have dx. Now allow me to put dx in the numerator. So this is going to be the integral of dx all over, and allow me to factorize this. Inside the square sign, I'm going to have 4 open brackets. I have 1 minus 3x squared all over 4. If you catch what I mean here. Expand this, you're going to get that expression there. And I'm going to take 4 out, which means I must take square root of 4. So what I have now is the integral of dx all over 2 square root of, and watch what I'm going to do on this part here. I'm going to write it as 1 minus, I'm going to write this part as root 3 all over 2x, and I must square the whole thing. The reason for that is because when you remove these brackets here, root 3 squared is going to be 3, 2 squared is going to be 4, and x squared is going to be x squared. You're back to that form there. Right, now I must take 2 out because it's a constant. So what I have is this is going to be 1 over 2, the integral of dx all over square root of 1 minus root 3 over 2x all squared. Now I'm going to, at this stage, let sine theta be equal to this. So let sine of theta be equal to root 3 over 2x. Obviously, differentiating both sides, we're going to have cos theta d theta is equal to, remember, there's just x here, so it will be root 3 over 2 dx. Now take this, divide by this both sides. You are going to agree with me that you're going to have 2 over root 3 cos of theta d theta is equal to dx. Now, the numerator here must be replaced by that. Here, this one must be replaced by that, and here I must have sine. So sine substitution continues, and this is going to be page 6 now. Page 6, and we're going to do it as follows. We just capture this here. I think you can see it from there. Yeah, you can. Let me move down a little bit more. Right. All right. So now we are saying, therefore, this integral, right? This integral then changes to 1 over 2. The integral of, instead of having dx there, I'm going to have 2 over root 3, and then cos of theta d theta all over, remember, square root of 1 minus sine squared theta now. And I showed you this in question number 2, that this is basically cos squared theta. Over here you can see cos squared theta equals 1 minus sine squared theta. So whatever is under the square sign must be replaced by cos squared theta. So now we're having 1 over 2, the integral of 2 over root 3 cos of theta d theta all over square root of this is actually cos squared theta. Now obviously this cancels that, and if I take this one out, remember this is multiplying, it's in the numerator, and this is dividing, so I'll basically multiply these two. So what I have now is 1 over 2 times 2 over root 3, and then the integral of cos of theta d theta all over cos theta, and these cancel, and what you have here is 1 over root 3, and then the integral of 1 d theta, because these cancel and you have 1, and this simplifies to 1 over root 3 theta, and I must say plus c, because this is an indefinite integral. Now the relationship between theta and x, our original variable. From here you can see that theta is just equal to sine inverse of this expression. So now I'm going to have my final solution is going to be 1 over root 3. I don't want to rationalize the denominator here. I can just leave it the way it is, 1 over root 3 sine inverse of this expression here, root 3 over 2x, root 3 over 2x, and I must say plus a constant c. This is the final solution to question number 3. Remember, we're talking about trig substitution, and so we have established now that if you have a square root of something minus something, it will be the sign substitution. If you don't have a square root, you just have a trinomial in the denominator, it will be tangent substitution. Let's look at question number 4, and that takes us to page number 7. Page 7, question number 4 is this one. The last question on trig substitution would be this in this video. Number 4, the question says integrate the integral of open brackets 4 plus cos theta all to the power minus half times 2 sine theta d theta. Right, so now the first thing is to deal with the negative exponent. So we approach this as follows. Question number 4, let's capture it as it is. We have 4 plus cos theta to the power minus half, and then we have 2 sine theta d theta. The first thing I have to do is to say, check this, the integral of this one here must come in the denominator, and power half is square root. Maybe let me take step by step. So this will be 1 all over 4 plus cos theta, and we're saying the power now must become positive half, and we are saying times 2 sine theta d theta. Now allow me to take this in the numerator, and this one here I'm going to write it as square root. So this will be the integral of 2 sine theta cos theta, sine theta d theta, not cos theta, sine theta d theta, all over. Now we're going to say square root of, watch this, 4 plus cos of theta. Right, now at this stage we're going to let this be equal to u, because now what we have is there's no square here now. So if I let, there's u substitution, if I let u be equal to 4, I want to let u squared, because I think there's a square root there. It will be better for me to say let u squared equals 4 plus cos of theta. Now if I differentiate both sides, I'm going to get 2u du on the left is equal to derivative of 4 is 0, cosine is minus sine theta d theta, and then I must take the minus to the left because there's a 2 sine theta there, and I'm going to have to need a 2 there. So let me take the minus to the other side. So I'm going to have minus 2u du equals sine of theta d theta. And here I have a 2, so I must multiply both sides by 2. So this is minus 4u sine, minus 4u du. Sorry about that. My hand is behaving against speed. So this will be, I'm going to come and fix this one. It's minus 4u du is going to be equal to 2 sine of theta d theta. This is exactly what I have there. It's exactly what I have here in the numerator. Right. I'm going to have to check the example number 2 if there was something that I erased and I never fixed. I would go back and check, but now for now let's just carry on. So what we have now is, here we must have du. Let me get another marker here. I do have it with another one there. What about this one? Right, so let me have in this place I'm gonna have my du. Fantastic. Now this is just perfect. Right, so now remember this expression is that in numerator there, so this must go in the numerator, and in the denominator I'm gonna have square root of u squared. See how nicely it comes out. So let's just come down here. Maybe I can squeeze it in here. This will be the integral of instead of having 2 sine theta d theta, I'm going to have minus 4u du all over. In the denominator, I'm going to have square root of u squared. Remember, this expression is u squared. Now from here, you can clearly see that if I go to page number 8 now, page 8, let me remove this page here. If I go to page 8 now, page 8, now we're gonna have, you can see it there. Yeah, you can. I just want to make sure that you can see it. All right, so this is gonna be, take the minus 4 out, minus 4, the integral of u du all over u, because square root of u squared is u. You can notice that these cancel. This is going to be minus 4, the integral of 1 du. Now, what is integral of 1? Well, is u in this case plus c. And what is u? Let's go back here. If you notice, u is going to be the square root of this, because u squared equals this, and therefore u will be the square root of this expression here. So this is going to be minus 4 square root of 4 plus, remember, square root of 4 plus cos theta, plus c, and that would be my final solution to question number 4. So basically looking like trig substitution question, but it's u substitution. So u substitution is very critical. It can be applied even in expressions that involve trig functions. So just be on the lookout for that. Right, we're going to page 9 now with our last question, question 5. Page 9, right, page 9 here, and question 5, question number 5, and the last one in this video. There it is. We're supposed to integrate the integral of sec squared, open brackets, 3 plus natural log of square root of x, close brackets, over x dx, and we're told x is positive, and obviously the square root of a positive number, a negative number, is not real. So looking at the square root of x there, x must be positive. And again, looking at the natural log, you can't have a negative natural log of a negative number does not exist. So this restriction here makes a lot of sense. But how do we approach this? All right, so as you would guess, we will say let u be equal to the expression inside the parenthesis, and then carry it from there. Let's copy the question now. It says here the integral of sec squared of 3 plus natural log of square root of x, or close bracket, divided by x dx here. Now allow me to take dx to the other side. This is going to be the integral of sec squared of 3 plus natural log of square root of x, and then times dx over x. Right, at this stage I'm going to let u be equal to 3 plus natural log of square root of x, and we have to differentiate both sides now. Watch carefully here, and I want to remind you something here. I want to remind you, let me use this page here. Please take note that square root of x is actually x power half. So differentiating the natural log, first du equals derivative of 3, 0 is a constant, and you're going to have to say 1 over square root of x times derivative of square root of x, and this is square root of x. And to differentiate this, remember the rule, multiply, subtract 1. So we're going to say here times 1 over 2 times x power 1 over 2 minus 1. Don't forget that. We're differentiating this part here, which is square root of x. Let's simplify this. Let's clean it up. So this is going to be 1 over square root of x times 1 over 2 times this one here is x power minus half, which is the same as 1 over square root of x times 1 over 2 times 1 over x power half. I told you that power half is square root. So this is just the same as 1 over square root of x times, let me bring it here, 1 over square root of x times 1 over 2. This is x. So you just have this root x times root x is x. So now we have, if you like, 1 over x times 1 over 2. And don't forget when you differentiate on the other side, you must set dx here. So I'm going to have dx there, dx, dx, and then finally dx. Now, so if I rewrite this on page 10, let me remove this page here. If I rewrite this on page 10, we call this page 10 here. Hope you can see it from there. Yeah, you can. So now I'm saying if I rewrite that, it's going to be, check this out, 1 over 2, and I'm going to say dx over x. And where am I coming from? I'm coming from du equals, this expression here. So du equals this multiplied by 2 both sides. 2 du is equal to dx over x. Now, this expression here is exactly that expression there. So I'm going to have 2 du there. I'm going to have 2 du in that place, and then I'm going to have sec squared of u, because this expression is u. So now I'm going to say, so the integral we have now is the integral of sec squared, watch this, u, and then 2 du, and take 2 out because 2 is a constant. So 2 integral of sec squared u du, and the integral of sec squared is actually tan, because derivative of tan is sec squared. Remember, the integration is the inverse operation of differentiation. So what is differentiation? The inverse operation of integration, the inverse of each other. So in this one here, it's going to be 2 tan u, and we must say plus a constant. Differentiate this, it will give you that. Do I have time here now? Let me just show you that derivative of tan is actually equal to sec squared. So we are saying y equals tan of u or x, and what is this? This is sine x over cos x. Don't forget that. And using quotient rule, dy dx will be equal to derivative of the numerator, which is cosine times the denominator, so it will be cos squared x, minus derivative of the denominator is minus sine times that is minus sine squared. Please take note, the derivative of cosine is minus sine. What is minus sine times sine? Minus sine squared. So minus sine squared, and we're dealing with that all over the square of the denominator. That's quotient rule. What do we have in the numerator? We have cos squared x plus sine squared x all over cos squared x. What is the numerator there? 1 over cos squared x. What is 1 over cosine? Secant. So this is actually sec squared x. So yes, the integral of this must be tan, because derivative of tan equals this. So here we go. So that's our final solution. But remember, we must go back to our original variable. What is our original variable? From here, u, the relationship between u and x is u equals 3 plus natural log of x, square root of x. So this is going to be twice tan of open brackets 3 plus natural log of square root of x, like so, and then we must say plus a constant. So this is our final solution to our integral number 4. And where is our integral number? Actually, integral number 5. This was integral number 5 right here, and through U-substitution we have been able, it's actually this one, which is of course that one there, of course this one here. So yeah, our final solution would be this one. This is where I'm going to stop in this video. I have many more videos coming up on integration, because integration is quite vast, and we haven't looked at areas area bounded by between two functions, volumes of revolution. We haven't looked at that yet on applications of integration. So if you are new to this channel, please support us by subscribing and inviting friends to subscribe. Help us grow the channel so we're able to generate many more videos and support as many students as possible. All right, God bless you next time.